So for the law of inertia, we have the example of a billiard table without friction, also without holes, but that doesn't matter. So there is no friction here, and a ball will travel in a straight line with the same speed as long as there is no force interacting. Of course, you see that the any one of these balls here are interacting with the sides of the billiard table and with each other. But look, for example, at the blue one. Whoops, not anymore the blue one, maybe now the orange one, as it just travels in a straight line until it interacts with something else like the sides. But otherwise they just keep on going. That's what inertia means. As I said, I turn off the friction completely, so all 5 of these here are actually never going to stop. And I'm going to turn on the friction in just a moment. Okay, friction is turned on now. And notice that they become really slow. Unfortunately, I was not able to actually produce friction between the table itself and the balls. That's why they keep on rolling. But other than that, every time they hit, there's some friction in between the sides and each of the balls and slowing them down. Okay, again, frictionless, so we have inertia is the only thing that applies, and as long as there's no force acting on them, they will just keep on going. I took one of the sides out, and as you can see, they just keep on going, and they're going to go forever off the screen. So here we have a force applied to a mass, and that would be Newton's second law. Acceleration equals force divided by mass, or force equals mass times acceleration. And as we can see, as this force is being applied to this object here, the car, it gets faster and faster, and that's the acceleration that you're seeing. So this little arrow here means the force, pushing it to the left. On this car here, I have doubled the force. So with more force on the same mass, we obviously get more acceleration. So it's getting faster, much faster. So here we have now a truck to which the same force is applied, but of course the truck has much more mass, so the acceleration is going to be less. In the previous examples, we have seen that a force can make an object move faster, accelerate it. Here, as the car is traveling to the lower left, we will see that a force is also able to change an object's direction. Okay, this is Newton's third law, action-reaction principle. So here we have a linebacker rushing the quarterback. Happens to be a really massive quarterback, tall. And a linebacker apparently is a little bit lightweight. And he carries a football too, but kind of ignore that. So here he goes at a relatively large speed, and as soon as he hits him, well, he's exerting force on the quarterback, but notice there's also force exerted on him. So here we have the quarterback running at the linebacker, who seems to be just standing in the way. And again, the linebacker in this case receives the force, but the quarterback is also being slowed down, is not running as fast as he used to. So overall, we have equal and opposite forces between the two, and even though they exert the same force on each other, the one to whom it makes more of a difference is the one with the lesser mass. As you can see, the one with the lesser mass gets a larger acceleration, which means we're actually taking Newton 3 and going back to Newton 2.